right, everyone. These notes are going to cover sections 7.1 and 7.2, which deal with root problems, and you can make calculations of the roots using your scientific calculator. So you should see what's called a square root symbol on your calculators, and you simply plug in the square root of 2,304. When you do that, you should get 48. Now, what does the square root mean? The square root is actually the opposite of squaring a number. So me squaring x is the opposite of me taking the square root of x. Now, you also have roots where perhaps you will see the square root symbol and an x on your calculator. So you would need to use that square root of x button to calculate any other root that's not a square root. So if you see a 3 there, a 4 there, or a 5, in this example, we have the cubed root of negative 216. And when you plug that into your calculator, you should get negative 6. That means that negative 6 raised to the third power should give you 216, negative 216. Now remember, if you see the square root symbol by itself, it means the square root, but we don't write the 2. Any other root, you will see the number represented. So you would see the 3 represented for the cubed root, or you would see the 4 represented for the fourth root. If you see just the root symbol by itself, again, that means square root. Now, when you're calculating any root and it's even, like the square root, the fourth root, the sixth root, any even root, you must have a positive solution. You can't get a negative number, because every time you square a number or raise it to the fourth power or any even power, you'll wind up with a positive solution. So you should not get a negative number if your root is even. If your root is odd, then you can get any number. You could get a negative number or a positive number. So in this example, we're asked to calculate the cubed root of 15. Now, when you substitute the cubed root of 15 into your calculator, you'll notice you get a decimal point. That is an estimation. So you aren't getting an exact value for the cubed root of 15. You're getting an estimation. So you want to use the symbol for estimate, approximately. This gives you an approximate value of the cubed root of 15. All right, now when you're dealing with the square root of, in this case, we have 36x squared. So when we're dealing with variables, now, first of all, the square root of 36, you can plug that into your calculator and you'll get 6. Now, the square root of x squared, you're being asked how many sets of 2 there are in x. So our x squared here, we have one set of 2. So we have 6 outside when we calculate the square root of 36. And then the square root of x squared is just going to be x. So our answer will be 6x. We have one set of 2. We're looking for how many sets of 2 there are in x squared. And it's only 1. So we pull out that 1x. That's the square root of x squared. In the next example, we're asked to find the sixth root of y to the 6th power. So now we're trying to find out how many sets of 6 there are in y to the 6th power. And there's only 1. So our answer is going to be y. Notice when our roots were even, our solutions were positive. All right, here we're asked to find the fourth root of 625. You plug that into your calculator and you should get 5. Now that means that 5 raised to the fourth power should give you 625. So that fourth root of 625 is 5. The seventh root of negative 1 is negative 1. Just plugging these into your calculators. Now, what do we do when we have fractions as our exponents, and we're asked to convert this exponential expression using radical notation. So when you have a root of a term, you can convert back and forth between the fraction form, the fraction exponent, and the root form. If you're asked to convert x to the 1/3 power to root form, that denominator is always going to be your root. So we put 3 in our root. That makes this the cubed root. The base of our exponent that goes underneath that square root symbol. And then the numerator becomes the power. So we have the cubed root. That cubed root comes from the denominator of our fraction. Our base of x goes underneath, and then we raise this to the first power. Now, raising something to the first power does not change the term. So the cubed root of x raised to the first power is the same thing as just the cubed root of x. This is our answer. All right, now we're converting 2,401 raised to the 1/4 power to root form. So we'll write our symbol. This 2,401 goes underneath the root. Our denominator becomes our root. So it's now the 4th root of 2,401. And we want to raise that 4th root of 2,401 to the first power. So we'll raise it to the first power. And again, raising a term to the first power does not change the value. So that just becomes the 4th root of 2,401. Now, the 4th root of 2,401 can be simplified. That gives you 7. All right, and looking at the next example, we're asked to evaluate -8 raised to the 5/3, or raised to the 5/3 power. So we're converting this exponential form to root form. Remember, our base, -8, goes underneath the root. Our denominator becomes the root, and our numerator is the power. So we have the cubed root of -8, and it's all raised to the 5th power. Now, when we calculate the cubed root of -8, when we punch that into our calculator, we'll get -2. So it becomes -2 raised to the 5th power. Again, we can plug this into our calculator. -2 raised to the 5th power gives us -32, and this is our answer. So first we want to change it from root form, and then we want to simplify until we can't simplify anymore. So we're changing to root form first. In this next example, we have 25/36, and all of that fraction is being raised to the power of 1/2. So our base, 25/36, is going to go underneath the root. Now we have 2 as our denominator. So remember, we don't write the 2 as our square root. We know by using this symbol alone that represents square root. But when we raise this term to the first power, it's just going to be that term by itself. So we're left with the square root of 25/36. And the square root of 25/36 is the same as me taking the square root of the numerator and the denominator separately. So we're dividing out and separating those terms in the numerator and denominator. So we have the square root of 25 divided by the square root of 36. And the square root of 25 we know is 5 in the numerator. The square root of 36 is 6 in the denominator. So 5/6 is our answer. In the next example, we have 27 raised to the power of -1/3. Now, first we want to simplify this negative power. Remember, to make a negative exponent positive, we move that term to the denominator. So we have 1 over 27 to the positive 1/3 power. Now, the denominator we're going to change to root form. The 3 is the denominator of the fraction, so that becomes our root. So we have the cubed root. That base of 27, we place that underneath the root. And all of this is being raised to the first power. But we know by raising a term to the first power, it just remains the same. So it becomes the cubed root of 27 in the denominator. The cubed root of 27 is 3. You punch that into your calculator. So you have 1 over 3 as your answer. Next, we have 25 to the 7/4 power divided by 25 to the 5/4 power. Since these terms have the same base, we can subtract their powers. So we keep that base of 25 and we subtract top power 7/4 minus bottom power 5/4. And 7/4 minus 5/4 gives us 2/4. From there, we want to reduce that fraction. So 2/4 can be reduced to 1/2. And then we change that form to root form. We have our square root symbol. Why? Because we have 2 in our denominator, so we know we don't have to write the 2. The base of 25 goes underneath the root, and this is being raised to the first power. So the square root of 25 raised to the first power is just the square root of 25. When you punch in the square root of 25 in your calculator, you'll get 5. That's your answer. All right, so now we have a to the 12th power, b to the 16th power, and then all of this, the entire expression is being raised to the power of 1/4. So we got to distribute that 1/4 power to each of the terms. So a to the 12th power times 1/4, and b to the 16th power times 1/4. Now 4 goes into 12 3 times, so this just becomes a cubed. 4 goes into 16 4 times, so this just becomes b to the 4th power. This is our answer. Now, if you would have chosen to convert the fraction to root form, you see you would get the same answer. We would make our root 4, so it'll be the 4th root of that base, which is a to the 12th power, b to the 16th power. And now we're looking for how many sets of 4 are there in 12, and there are 3 of them. How many sets of 4 are there in 16? There are 4. So you see you will get the same answer if you change your fraction to root form or if you distribute that power. Next, we have x raised to the 7/5 power and times x raised to the 3/5 power. Now, when you're multiplying terms with the same base, you keep the base and add the powers. So we're adding 7/5 plus 3/5, which gives us 10/5. And 10/5 simplifies, that reduces. 10 divided by 5 gives us 2. So our answer is x squared. In this next example, we're rewriting. Make sure that you use positive powers. You want positive exponents. So we have x raised to the power of 11/6, and it's times, or it's all being raised to the negative 6/7 power. So first we're going to multiply power times power. 11/6 times negative 6 over 7. We're multiplying these terms. And when we do that, these 6's are going to cancel. That leaves this negative symbol in the numerator times 11. That's negative 11 times that 1 right there, or negative symbol, right? And then your denominator, you have 7. So you're left with negative 11/7 when you simplify that term. That negative exponent has to be written in positive form. So we need a positive exponent. So we move that fraction to the denominator. It becomes 1 divided by x to the positive 11/7 power. And this is our answer. Make your negative power positive and you're done. In the next example, we have 125 times x raised to the 15th power and y to the 6th power. This entire expression is being raised to the 2/3 power. So we change it to root form. Our denominator of 3 will be moved to become our root. So it becomes the cubed root. The base, 125 x to the 15th power, y to the 6th power, we put that underneath the root. And then we raise that entire expression to the second power. Remember your numerator. Now we're going to simplify where we can. So we'll take the cubed root of 125, that gives us 5. The cubed root of x to the 15th power, we want to know how many sets of 3. Just divide 15 by 3, and you'll get x to the 5th power. Y to the 6th power, to get the cubed root of y to the 6th power, again, you just divide by 3. We want to know how many sets of 3 there are. Divide by 3, we'll get y to the 2nd power. Now remember, this entire expression is being squared, so we carry down our power of 2. Now we want to distribute that power. So 5 to the 2nd power gives us 25. X to the 5th power, when we raise that to the 2nd power, we get x to the 10th. And then y squared, when we raise y squared to the 2nd power, we get y to the 4th power. This is our answer. 25 times x to the 10th power times y to the 4th power. All right, that's the last example from this section. We'll stop here.